Because it looks like heart, it is not that heart. Please don't draw like this. It is not that heart. Definitely not. Okay. So it looks like that. So I have seen normally when people draw, they start drawing heart. Hello ladies and gentlemen, your captain speaking on flight deck. My name is Captain Surinder Singh. Welcome aboard the plane talking. Sit back, relax and enjoy your journey. I don't have any trick, okay. So we will see how ADF NDB works. When we started with this topic, we discussed that this was the first ever navigation aid invented. There was nothing before this. The navigation was visual navigation. There was no navigation equipment as such which you have in the cockpit can take you to the one point. This equipment, when it was invented, it was called loop scale equipment, LSE, and it was not automatic direction finder. We saw that how this RBI cockpit indicator is, and the tuning panel, and on the ground station also. So this equipment actually was loop scale equipment, and the reading was LSR. Later on, things improved. This navigation aid got improvised. Presently, it is out of ICAO standard equipment procedure, so it is not taken as standard equipment. Why? We will see that, because to use something in the cockpit, the system, whichever system you are using, it should be able to generate alert or warning in case of failure. The biggest drawback of this equipment, as we learn, is if it fails, there is no way to understand. There is no way to know. So that's why you tune the frequency. It is written 245, and this is the pointer, RBI. Here, it could be here, doesn't matter, they all are same size. And this pointer is always pointing towards the station, the relative bearing with respect to heading of aircraft. Now the problem is that, let's say my pointer is stuck. There is no way in this equipment to know. It is not working. So that's why in 2009, it was 8 or 9 somewhere, it was removed from ICAO standard equipment list. Flight plan, we will see there is something is called standard equipment. So in that standard equipment, it is no longer there. So that's why, but the best thing is this, everything, whatever came, it came after that. So this is the basis of all understanding. We already seen heading, relative bearing, two things. As we progress further, we will add another radial something called NVOR. Now how it works? All I want is this pointer to be pointing towards the station. I turn left, right, do whatever. I have my heading may be anything, but this pointer should point towards the station. That's what we want. So how it is achieved? Let's see. So obviously this is on ground and this is in aircraft. And we have already seen purpose is it gives relative bearing. How it works? Principle of working of NDB is bearing by loop theory. We will see what is this loop theory. Okay. It works in frequency. For ground station NDB, which is on ground, it works from 190 to 450 kilohertz. Whereas ADF, which is in the aircraft, you can tune the frequency from 190 to 1750 kilohertz. So the bandwidth for the receiver in your aircraft is much more. If I am putting a ground station, like you have FM you can, the lowest you can go to some 88 point something, and the highest you can go up to 107 point something. So ground station, if you are putting it, is something like this. Similarly, but that works in megahertz, in VHF band. This is in which band? kilohertz band. So kilohertz is easy with like VLF, LF and MF. So the ground station works in this where a receiver is from 190 to 175 and there's an overlap. LF is from 30 to 300, okay, and MF is from 30 to 300. So there is an overlap. Now why this frequency for the receiver in the aircraft is more? Because this was the first navigation aid which was invented. They were not available. So whoever invented, they designed the equipment in such a manner that you could tune to the MF, or rather you can tune to medium wave radio. Nowadays FM works in megahertz. No one uses AM radio. Amplitude modulation in the car also you have AM, nobody uses it, but you have All India Radio which still transmits at in AM. The frequencies are 1368 kilohertz, 666 kilohertz or 648 depending upon the station. So all these frequency were used by medium wave radio in MF band. So the equipment is designed in such a manner that I know, let's say if I'm going to Udaipur and there is a radio station, and if I know the frequency, you can tune the frequency and the pointer RBI will show towards that. But the equipment is designed in such a manner that you can actually tune and you can navigate from point to point. You can tune the frequency, you can listen to the commentary. Please don't do it. In fact, earlier, Airport Authority of India, they used to publish a book, Air Radio, in which all the radio stations frequency along with the timing used to be given. That was called Air Radio. That book was called Air Radio. But if I know there's a radio station, you can tune it. It will point towards that. It has got identification code, Morse code. Okay, so that's why the bandwidth of the receiver was more to receive AM radio. So band, there is an overlap. It is in high LF and low MF band, correct? It is an overlap. So bearing by loop theory. Now, what is this loop theory? We will see. What is my aim? My pointer should always point towards the station, RPI pointer. That's my aim. So this is done by something, what they referred is that loop theory means the aircraft equipment consists of antenna, which has got directional property because All India Radio, let's say it is playing a song. Whatever the radio station is transmitting, it is a normal song, correct? Or the news, whatever is playing, it has got no directional property. It is just a radio wave in this frequency. It's got no directional property. A song is playing, radio wave is coming. How your pointer will point towards that? That's what you want. A loop antenna looks like this, exactly like this. It has got two arms. You have vertical arms and horizontal arm. Now, let's say this is the ground station and it is transmitting. This is NDB or your radio station, normal radio station. It is transmitting a radio wave, and in the aircraft you have this loop antenna. Just for understanding, I am drawing like this. Don't go ऊपर aircraft के. ऐसा तो कुछ है ही नहीं है. This is just for your understanding. There is an antenna inside. Okay. Now when you are flying, whatever this radio signal is coming, it is reaching in different phase. Or when you say phase is when you give the position of a wave in terms of angle. When I say wave is at 45 degree means the angular position of wave is at 45 degree. Here this wave is at 90 degree. The phase is 180 degree. Here it is 270 degree. So when you refer to a wave position in terms of angle, it is called phase. So during one cycle, wave starts from 0, goes to 180 and then completes at 360. So that is the phase. Angular position of a wave at a given time is called phase. Now this will be received in different phase in both this vertical arm of the loop. Now because of this different phase, there will be a potential difference. Now if this antenna is there, what is the purpose of this antenna? To capture whatever the radio signal or electromagnetic disturbances are there. That's what it may be, some nanovolt or very less, captures it, and then we process it to extract the information. So in this antenna, it is reaching at the different phase, and because of this, a potential difference means one side more charge, one side less, and that will cause some current inside this antenna. That is called induced EMF. Inducing EMF is electromotive force. That's what is EMF. Basically, some electron will flow in this. And you say current is what? It is flow of electron. And current always flow from higher potential to lower potential, means one side electrons are more, one side is less. And that's what will cause EMF. When this antenna is in line with the station, let's say this is my transmitter, okay, it is transmitting. When I am in line with this, both these arms are receiving in different phase, so there will be some current produced inside this, there will be some output of this antenna. Loop aerial in line with the station. So output will be, maximum current will be induced. Okay. Now let's say when this loop aerial is exactly 90 degree to the ground station, what will happen? Both this arm will receive at the same phase when it is exactly 90 degree. There will be no potential difference, there will be no output from this loop aerial. So when this loop aerial is when this loop aerial is exactly 90 degree to the ground station, the output will be 0. So this loop aerial is got a directional property. The signal which is coming, it is a song. So when loop aerial is in line with the station, the output is maximum. In simple way, let's say if I don't want to go into too much of physics or potential difference or EMF, the output of this, whatever this is capturing, is maximum. Whenever it is 90 degree, the output is 0. So this antenna has got a directional property, and that's why this principle of loop theory means all I need to do is I put maybe a meter to measure the current. Whenever the output is maximum, means it is in line. Whenever the output is 0, it is 90 degree. But there's a problem here. When it is exactly in line, the output is maximum. But what about the station is here then? Then output still will be maximum. Correct? Here the output is 0, but what about the transmitter is here? It is still will be 0. So this simple loop aerial is got directional property, but it suffers from something called 180 degree ambiguity. Means there is a confusion. There are two maximum position and two 0 position. There is a problem. You can't say station is this side or this side, let's go. Oh, sorry, it is this side. You can't use it for navigation. Are you understanding? So that's why a simple loop aerial has directional property, but it suffers from ambiguity. Is the word is from ambiguous, something is not clear. So the ambiguity is that the station from 2 position, this antenna output will be maximum, and from 2 position the output will be 0. Okay, but for navigation I want exactly my pointer to point towards the station. That's what you want. You can't have 180 degree. Now to resolve this 180 degree ambiguity, we add another aerial. So examination question, which aerial suffers from 180 degree ambiguity is your loop aerial. Clear on this? To resolve 180 degree, we use another antenna aerial, which is called sense aerial. Now the sense aerial is a normal vertical aerial like FM or radio antennas which you see. It is a vertical antenna which will receive signal from all the direction. Polar diagram is a diagram drawn either for the receiver aerial or for the transmitter aerial. Now polar diagram gives the directional propagational characteristics. Directional propagational characteristics in the sense propagation is spreading, how it is spreading. If I put an antenna like this vertical, which all direction it will spread? In all 360 direction. So polar diagram will be a circle. So polar diagram, mainly there are two types. You have omnidirectional, means any antenna which can receive from all the, it is like a light bulb. You switch on the light bulb, which all direction signal will go? All 360 degrees. So polar diagram will be a circle. Similarly, you have those directional antenna like a flashlight or a torch light. In that, what will happen? All the energy will be concentrated only in that beam, or in that is called lobe, L-O-B-E. So it can be for transmitter, it can be for receiver also. You have a dish antenna from where all you can receive the signal only in a particular direction. That's how it is. So you have a loop aerial. This has got its polar diagram. A sense aerial is a vertical aerial with a polar diagram as circle. Now output of both these aerials is processed to make the pointer always pointing towards station. That's what you want. Whatever you do, pointer is always pointing towards station. So how it works is basically a loop aerial which is like this. It will receive signal in both this vertical arm at different phase. So we have loop aerial. One is positive, obviously one is negative because of potential difference. And these two arms will receive signal like this. It can receive from all 360 degree direction, and this can also receive from all 360 degree direction. That's how this figure of 8 is. In all the direction, this is also. So the net resultant is the polar diagram of loop aerial is, or the output is, that's how it is given. Figure of 8. And you have another antenna which is a simple vertical antenna which is referred as sense aerial. Both are together. What about this aerial will receive signal from all the direction, equal amount. So the polar diagram will be a circle. So that is a polar diagram is a circle. So one antenna is getting maximum signal, one depending upon which direction the station is. One side more, one side less, plus and minus. The output of both this antenna is processed electronically. They are processed together, output, and then the resultant which comes. This is for loop aerial, which is receiving same amount from all the direction, and then you have both are combined and processed. The resultant is one side signal cancels, one side is added up. So the resultant shape which it forms, something like this. One side signal adds up from both the antenna, one side cancels. So it has got only one maxima and one minima, which is called null point. And this shape looks like heart. Anything which looks like cube is cuboid. Anything which looks like sphere is spheroid. Anything which looks like heart is cardiac, say they have used this term. So because it looks like heart, it is not that heart. Please don't draw like this. It is not that heart. Definitely not. Okay. So it looks like that. So I have seen normally when people draw, they start drawing heart. It is not actually heart, it is a more of a circle kind of thing. one side signal is added up, one side is reduced. The shape is cardioid. या इसी इन द नोटबुक ना लोग ऐसे बना रहे होते हैं पूरा कि सरदार को ड्राइंग बनानी नहीं आती, मैं बनाऊंगा, मैं तो पूरा बनाऊंगा. ओके, so this is cardioid, and cardioid it has got one maxima and one minima. So now the problem is resolved. Now there is another problem. Obviously we know that one side the signal is coming maximum and one side is minimum. That is confirmed. This side is maximum. But how do you know it is maximum? There is no way to find, because if you are far away, what will happen? The output will, that attenuation take place. A wave loses its energy. If you keep going away and away, what will happen to this maximum signal? It will keep reducing. Now, is there any way to find out? There is no way to find out what is maximum. If I come closer to the station, more. So this is another problem. I want my pointer to point towards station, correct? But if I use this maximum point, this maximum, here maximum is different, here maximum is different, I go away, maximum will be different. So again they use one more intelligent method to make pointer always point towards station. What about null position? The null position is fixed irrespective of wherever you are. Wherever you are, the null is null. Zero output means antenna is always 90 degree to the station. This null position is used to move the RBI pointer, because null is fixed. If the station is here, because there is one null, so it always pointing towards the station. This will be null. So my pointer, if this is my pointer, I want always point towards the station. So this null position is fixed, where this output will be 0. So earlier they used to do manually. That's why it is called loop scale equipment. Wherever the output comes 0, pointer, the station is exactly 90 degree to this. Let's say I'm sitting in cockpit or wherever, I want to find out where the station is. I tune the frequency and start rotating it. Now wherever it comes 0, that is the station. That's what's called loop scale reading. Later on, as the technology improved, they made modification in this, and it became automatic direction finder. It is, whole thing is now more of electronic kind of thing. The moment you move in one direction, what will happen? There will be some output. That output is processed to rotate a servo motor kind of thing, which will again make the output 0. If it try to go this side, now it will be in the opposite direction. Some output will be there, again it will make it 0. So that became automatic direction finder, ADF. So it doesn't matter ground, whether it is news is playing or something, you get the radio signal, you process it with the loop antenna, you go in, let's say, if you try to go in any direction, there will be some output. Now that output is used to, given to a motor, which will again put it to 0. It will ensure that output of this aerial is 0. Now as long as this output is 0, the pointer is always pointing to a station. Now you do whatever, whichever side your heading is, the pointer, the RBI pointer is always pointing towards station. So that is the simple working of NDB and ADF. Please copy this. ये खत्म कर दें इसको. Yeah. Okay. Please copy this, and we'll have a break after this. You after the break. This is your captain speaking. हाँ अब बोल चल.